Yep, section 6.2 is called parallelograms. On page 399, they're going to give us a definition, and they're going to give us several theorems dealing with parallelograms. And these theorems will be about the properties of a parallelogram. So our only learning target for the day is to know and use the special properties of a parallelogram. But it's a bit more complicated than that because there's several properties. Okay? So if we start here on 399, we need to know what a parallelogram is, first of all. Definition. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. It's a four-sided figure. It is a quadrilateral. And according to the definition, the first special property you need to know is that both pairs of opposite sides are parallel. So on the one they have for us here, the top is parallel to the bottom, and the right side is parallel to the left side. Okay? So parallelograms have both pairs of opposite sides parallel. And it's got to be both, because there are other things that we're going to study later called trapezoids that have one pair of parallel sides. They look more like this. Okay, where those would be parallel. So it's got to be both pairs of sides, both pairs of opposite sides parallel. And then to name a parallelogram, use the little symbol here that looks like a very small parallelogram. And then you just start at one vertex and you go around. Generally, we go alphabetically if we can, A, B, C, D. So we would read that as parallelogram A, B, C, D. So in parallelogram A, B, C, D, segment BC is parallel to segment AD, and segment AB is parallel to segment DC by definition. All right, the definition is that both pairs of opposite sides are parallel. All right, now to get to our other properties, we have to get to these theorems. So if we keep looking on 399, we have these four theorems all in one little box. All right, and they're the properties of parallelograms. So the first one says, if a quadrilateral is a parallelogram, then its opposite sides are congruent. So we already knew that the opposite sides were parallel. This theorem says that opposite sides are congruent. So in this one here, segment JK is parallel to, or is congruent to segment ML, and segment JM is congruent to segment KL. So not only are opposite sides parallel, they are also congruent. Next one, if a quadrilateral is a parallelogram, then its opposite angles are congruent. All right? Now, we talked about consecutive angles back when we talked about transversals. You know, we'd have something like this, and we'd say angle 1 and angle 2 are consecutive angles. Keep that in mind here. Angle J and angle M would be consecutive angles. Angle J and angle K would be consecutive angles. All right? So then what would be the opposite angle to angle J? The one across it on the other end. So those are the opposite angles. So angle J is congruent to angle L because opposite angles are congruent. And then angle K is congruent to angle M because the opposite angles are congruent. So in a parallelogram, opposite angles are congruent. Still with me? So we have three properties so far. In a parallelogram, opposite sides are parallel, opposite sides are congruent, and now opposite angles are congruent. Let's keep going. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. All right, back to this idea. We know that if two parallel lines are cut by transversal, that consecutive angles are supplementary. We've known that for months. Well, what if I made a parallelogram out of that? Wouldn't angle 1 and angle 2 still be consecutive angles, and wouldn't they still have to be supplementary? And it works for all of them. So the next one here was, if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So angle J and angle K are a pair of supplementary angles. Angle K and angle L are a pair of supplementary angles. Angle L and angle M are a pair of supplementary angles. Angle M and angle J are a pair of supplementary angles. So any way you can pair up consecutive angles, they are supplementary. You with me? Last one in this box. If a parallelogram has one right angle, then it has four right angles. Here's why. We already know that in a parallelogram, consecutive angles are supplementary. So if that's a right angle, wouldn't this angle that's consecutive to it, angle M, have to be supplementary to it? And what's supplementary to a 90-degree angle? Another 90-degree angle. Now, I can do that all the way around the parallelogram, or I can say opposite angles are congruent. So if that's 90, that's 90. And if that's 90, that's 90. No, it's a rectangle, though. Doesn't have to be a square, but it is a rectangle. So in other words, and I'm glad you said that. In other words, they could have worded this differently, and some books do. If a parallelogram has one right angle, then it's a rectangle. Okay? All right, so I'm going over these kind of fast. I don't mean to, but each individual property is fairly simple and easy to work with. It's just that there's a bunch of them. So what you have to remember so far is that if a quadrilateral is a parallelogram, then we know these things. We know that opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and if there's one right angle, all four of them are right angles, which makes it a rectangle. Okay? Everybody with me? All right. Now, we also have a property about the diagonals of a parallelogram. And it says this, or the first one says this. If a quadrilateral is a parallelogram, then its diagonals bisect each other. So the diagonals of a parallelogram bisect each other. They don't have to be congruent to each other, but they bisect each other. So if I look at this figure here, parallelogram ABCD, I know that the diagonals bisect each other. And remember what a diagonal is. We talked about this yesterday, or actually the day before, I think, when we started with polygons. A diagonal connects non-consecutive vertices. So in this figure, segment AC is a diagonal. Segment BD is the other diagonal. And that's all of them. There aren't any more. Okay? They bisect each other. They cut each other into two equal halves. That means that segment BP is congruent to segment DP. It also means that segment AP is congruent to segment CP. Okay? The diagonals bisect each other. And the other property dealing with the diagonals of a parallelogram says if a quadrilateral is a parallelogram, then each diagonal separates the parallelogram into two congruent triangles. So, looking at parallelogram ABCD again, but I only draw in one diagonal. Okay, it doesn't matter which one, but I draw in one. This theorem says that those two triangles formed are congruent to each other. And it's real easy to prove by side, side, side. We already know that since ABCD is a parallelogram, we know that segment AB is congruent to segment CD. We know that segment AD is congruent to segment BC, don't we? Because opposite sides of a parallelogram are congruent. So since it's a parallelogram, opposite sides are congruent, we've got those congruent segments. Well then, good old reflexive property, right? That's congruent to itself. So aren't those two triangles congruent to each other by side, side, side? Okay. Define a bunch. No. All right. So we've got several different properties of parallelograms that you need to know. Okay? So they're all listed for you in your book. In the past, some students have made just like they've written them all down in one little place so that they're all there in their notebook. I don't care. What I do care about is that you know these properties. So you need to know, let's start off with this hypothesis, this given, that it's a parallelogram. You got to know it's a parallelogram. And if you do, you know that the diagonals bisect each other. You know that each diagonal separates the parallelogram into two congruent triangles. You know that if there's one right angle, then there are actually four right angles. You know that consecutive angles are supplementary. You know that opposite angles are congruent. You know that opposite sides are congruent. And you know that opposite sides are parallel. That's a lot of properties you got to know. Okay? So make sure you know them. Any questions? All right, let's do a little work. On page 403, get out the paper you're going to do your assignment on, because this is part of your assignment. All right, number one. This is a navigation problem. I've always wanted to know how to navigate. To chart a course, sailors use a parallel ruler. One edge of the ruler is placed along the line representing the direction of the course to be taken. Then the other ruler is moved until its edge reaches the compass rose printed on the chart. Reading the compass determines which direction to travel. The rulers and the crossbars form of the tool parallelogram MNPQ. So I can't see it on mine. Can y'all see it? The parallelogram they want us to see. It's this. Yeah, it's there. Actually, it's probably the outer edge. It's there, and there, and then there, and then there. That's the parallelogram formed by those two rulers. Okay? So let's see here. Let me draw a different one so it's a little easier to work with. So we'll just say it's that. Now, they called it MNPQ, so I may not get my vertices in the same order they intended. Angle M. So if I call that M, N, P, Q. All right. They said for part A, if the measure of angle NMQ, which I would have just called it angle M, right? I can call it angle M. There's only one angle M. So if angle M has a measure of 32, find the measure of angle MNP. Find the measure of this one. So we got to know a property. Those are consecutive angles. And in a parallelogram, what's true about consecutive angles? They're supplementary. So what's 180 minus 32? 148. So the answer for A is 148. For B, if the measure of angle MQP, so angle Q is 125, find the measure of angle MNP, this one. Well, those are opposite angles. Since that's a parallelogram, what do we know to be true about opposite angles? They're the same measure. They're congruent. So that measure of that angle must be 125. Okay? For C, oops, there we go. For C, if the length of MQ is 4, what's the length of NP? Opposite sides are parallel, but opposite sides are also congruent. So it's 4. The angles do, yes. All right, the question was, do the angles in the parallelogram equal 360? Yes, because a parallelogram is a quadrilateral, and if you did this, you'd get 4 minus 2 is 2. 2 times 180 is 360. All right? Let's try another one. Number 2. Find the value of each variable. All right, for number 2, they don't, well, they do. They say, the directions I copied don't say that this is a parallelogram, but in your book it says find the value of each variable in each parallelogram. So this is a parallelogram. Since it's a parallelogram, we've actually got 2 different ways we could work this problem. Consecutive angles are supplementary, so I could add the measure of angle L to the measure of angle M and make it equal 180, but opposite angles are congruent, so I think the easiest way is to say the measure of angle L equals the measure of angle J. Don't you? Add 1 to both sides. 2x equals 76. And what does x equal? 38. Item number 3. This time our variable is in the expression that gives us the length of one of the sides. All right, all we know about the sides is that opposite sides are parallel. Well, that's not really going to help us find the length, is it? But opposite sides are congruent. There's no relationship as far as the length goes between consecutive sides, but opposite sides are congruent. Well, that means y minus 4 has to equal 11. So what does y equal? 15. Everybody still with me? All right, number 4. We're still trying to find the value of each variable, and these are still parallelograms. All right, what we've got going on here is they're giving us lengths of these portions of these diagonals. So what is it that we know about the diagonals of a parallelogram? What do they do to each other? They bisect each other. Okay, they cut each other into 2 equal halves. So here on number 4, that segment is congruent to that segment because that diagonal got bisected, and that segment's congruent to that segment because that one was bisected. Okay, so that means that a minus 7 equals 2, and doesn't it also mean that 2b minus 6 equals 10? All right, we can solve those. So a equals 9. Oops, that looks like a negative 9 for some reason. A equals 9. Add 6. 2b equals 16. B equals 8. All right, we good? All right, number 5. Diagonals again. They still bisect each other. So that segment's congruent to that segment, that one to that one. Well, we can set up equations then, can't we? We can say that 2b plus 5 has to equal 3b plus 1. And can't we, well, you tell me, what's the other equation we can set up from this? And there we go. Okay? So all we got to do now is solve them. So, solve them. You solve them on your paper, and I'll solve them up here after you get started. And did you get what I got? I got B to equal 4 and W to equal 5. All right, any questions? All right, let's take a look at number 6. It says determine the coordinates of the intersection of the diagonals of parallelogram ABCD with vertices A, then B, then C, then D. Wow, the coordinates of the intersection of the diagonals. Anybody have an idea? Easier than the distance formula. All right, let's look at this one. Let me erase this stuff. Let's pretend that it's on a coordinate plane and all. But remember how, since that's congruent to that, doesn't that mean that point is the midpoint of that diagonal? And since that's congruent to that, isn't that very same point the midpoint of the other diagonal? So what we can do is simply find the midpoint of one of the diagonals. They have the same midpoint, don't they? That one point is the midpoint of each one. So if I can use the midpoint formula to find the midpoint of one of the diagonals, it must also be the midpoint of the other diagonal, and it must also be then where the diagonals intersect. Do you follow that logic? Yes or no? Okay. Now I've got this problem. So I've decided that the way to work this is to find the midpoint of one of the diagonals. How do I know what segment makes a diagonal without drawing this out? I mean, I can draw it out and figure it out, okay? I can't. But without drawing it out, how do I know what segment is a diagonal and what segment is a side? It goes through the inside. So look, AB is a side, isn't it? BC is a side. CD is a side. DA is a side. You with me? Well, so isn't AC a diagonal? So segment AC, you don't have to write this part down. Segment AC is a diagonal. What's the other diagonal? BD. Segment BD is a diagonal. So find the midpoint of either one. Okay? So let's get the midpoint of segment AC. To get the midpoint, remember how that works? You add the x coordinates of your end points together and divide by 2. Then you add the y coordinates of your end points together and divide by 2. So if I'm using A and C, add the x coordinates together, -4 plus 4, divide by 2, and then add the y coordinates together, 6 plus -2, and divide by 2. Well, -4 plus 4 is 0. What's 0 divided by 2? 0. 6 plus -2 is 4, and 4 divided by 2 is 2. So that's the midpoint of segment AC, which means it's also the midpoint of segment BD, which means that's the intersection of those two diagonals. Now, maybe it's just because I've been doing this for a while, but here's what I think about what we've done so far. I think that there's a lot of properties to know, but I think actually once you decide what property to use and how to use it, the problems work out fairly well, don't they? The ones we've done so far have. So it's the knowing what property to use and then how to use it that's going to be the tough part. Because you can know that the diagonals bisect each other, and it still may not enter your mind to find the midpoint of one of them to work this problem. Okay? So you're going to have to think. You're going to have to figure out what property to use and how to use it. Sometimes it'll be obvious, but sometimes, like this one, it won't be all that obvious. Okay? And then we get to a proof. We haven't done a proof in a long time, so let's do a proof. This is a short one. This will be about 3 steps, and maybe 4. All right. They want us to write a 2-column proof. We're given that ABCH and DCGF are parallelograms. So each of those little two blue figures are parallelograms. We have to prove that angle A is congruent to angle F. Statements, reasons. What are we going to put as our first statement? The given. So we write A, B, C, H, and D, C, G, F, R, parallelograms. Reason one, given. All right, now, statement two. All right, let's plan this out before we get to statement two. We know that in a parallelogram, opposite angles are congruent. So don't we know that angle A is congruent to angle C? And we've known for a long, long time that vertical angles are congruent. So the angle C on the left and then the angle C in the other parallelogram are congruent to each other. And then can't we use the same thing we just started with, that the opposite angles in a parallelogram are congruent? So that angle C has to be congruent with that angle F. So is an angle A congruent to angle F? Yeah, it is. It's easy. Now we just got to write it down. Now, to avoid, I can save a step if I do it like this. Okay? I'm going to say that angle BCH is congruent to angle GCD because vertical angles theorem, or vertical angles are congruent, if you'd rather write that. So that gives me that so far. All right, on the figure, I've just got those two angles. Now, and the reason I'm doing it this way, because I can put both of these angles, I can use the fact that the opposite angles in a parallelogram are congruent in one step. I can do that twice, right? One reason, two different statements. So I can say that angle A and angle BCH, oops, no, wait. Angle A is congruent to angle BCH, and angle GCD is congruent to angle F. Now, the reason. Well, the reason is the theorem that says if a quadrilateral is a parallelogram, then opposite angles are congruent. I think if we write it this way, we'll be okay. In a parallelogram, opposite angles are congruent. So I saved a few words by rewording that a little bit. All right? Now, so follow the logic here. If angle A is congruent to angle BCH, and angle BCH is congruent to angle GCD, and angle GCD is congruent to angle F, angle A is congruent to angle F. But do you know what to put for the reason? All right, two different reasons can be written down. It can be the transitive property. That's, if A is equal to B and B is equal to C, then A is equal to C. That's what we're doing. So it can be transitive property. But the transitive property is really just an example of substitution. So if you put substitution, I'll count that as well. You don't have to put both. In fact, don't put both. But either one, I will count correct. The book would rather you write transitive, but I'm fine with substitution. Okay? All right. Now, are there any questions? Here's your assignment. and 8. So, page 403, 1 through 6, 8 through 23, 31 through 37, 46 through 49.